Hi class, welcome to today's lecture. So from today we will talk about the shear and moment diagram. So today we will talk about part 1. We'll get started by talking about what's a shear and what's a moment diagrams and how to draw a shear and moment diagram with 2 examples. So in next lecture, I will give you more examples. So before we get started with today's new knowledge, let's have a quick review of what we already discussed so far. So for any beam, so it's in the internal force in the beam. So let me draw a beam here. So for any beam, if we cut it, okay, we will have shear force, which is way here, and normal force in the axial direction, and also you will have a moment. Okay. And N is the axial force, which is the normal force. V is the shear force. And M is the moment. And those two will change along beam. And the thing we are going to talk about today is how to find the change of the shear and the moment and show them in a diagram. Okay. So what are the steps? Okay. How to get the moment and the shear diagram. So first is to plot the internal force, okay? Includes the shear force and the moment, okay? We draw those forces into separate graphs. So those forces very important to design beams or columns. And you will also need to learn those things in your future class, like mechanical of material and structural analysis. So here are some steps, okay? So how to draw the free body, how to get the shear and moment diagram. First, we need to draw a free body diagram. To solve for the support reactions. And then you need to draw the shear diagram and then draw moment diagram. using the shear diagram. So here are some notes. Both shear and moment diagram, okay, they must start and end and 0. For the moment and support, counterclockwise is positive, clockwise is negative. And for the movement along the beam, if you found a counterclockwise movement, your movement diagram like move up, downside. If you found a clockwise, it's move upward. Okay, I will show you later. For example, here's an example, okay? You have the beam and you need to draw the shear and movement diagram for this example. As we already discussed, okay, what you need to do first. Okay, first you need to draw the free body diagram to solve for the support reaction. Here, okay, here is a beam. There is a pin. You have AX, AY, and you have BY, and also you have the 5 kilonewton on the middle. And here is a dimension 2 meter and 2 meter. So you are given the load on the beam, and you need to find like reactions. Okay. So what we did in previous lecture. So it's a time to use the 3 equation of the equilibrium. So for example, first one, sum of moment on point A is 0, which means negative 5 kilonewton times 2 meter plus By times 4 meter equals to 0. Okay. In this way, we saw By equals to 2.5 kilonewton. And our second equation will be sum of Fy equals to 0. Ay minus 5 kilonewton plus 2.5 kilonewton equals to 0. And we can solve Ay equals to 2.5 kilonewton. What about Ax? Okay. Before I write down this equation, Ax plus what? Okay. Ax is only horizontal force, so we can just write Ax equals to 0. Okay. So with all this information, it's time for us to draw the shear in the moment diagram. So here is the beam, 2.5 kilonewton here, another 2.5 kilonewton here, 5 kilonewton here, and here the distance is 2 meters. Okay, For the shear diagram, you need to draw its dimension and unit. Okay, very clear. So x is united in meter, and the shear force is in kilonewton. So as we discussed before, the shear force starts with 0 and ends with 0. And also because we have 2.5 reaction and point A, it makes our shear force go up to 2.5. Okay, and we keep moving on because nothing, no new force, okay, between the point A until the middle of the beam. So that's why it's a horizontal line until the middle. And then you have a 5 kilonewton in the upside direction. We need to move our shear diagram upward by 5 kilonewton. So which means, and similar, we move forward here until point B, we have another 2.5. So we move it 2.5 upward. Okay, so here is 2.5. So that's the shear diagram. Okay. And how to draw the moment diagram? And you already learned from the calculus. Okay, so you should be very familiar with the integral. So as long as you get a shear, okay, the movement will be integral of the shear, which means mx will be the integral of the vx along the dx. So for example, the moment from 0 to 0.5 will be the integral of the 2.5 from 0 to 2.5. Okay. So it will be 2.5x bounded by 0 and 2. This will be just 5. Okay. And also the integral between the 2 to 4 is a negative 2.5 dx. It will be negative 2.5 2 to 4, which is negative 2.5. Okay, so like a moment diagram, it starts from 0 and ends with 0. The integral on 0 to 2 is 5. So which means on point 2, our movement will be 5, just connected by a line. And from 2 to 4 is negative 5. Decrease, keep decrease until 0. Okay. That's how we draw the movement diagram from the shear diagram with the integral. And also, we have another way, like after we draw the shear diagram, we can calculate what's the area. So the area is 5 here. Area is also negative 5 here. So which means our movement diagram will be moved upward by 5, okay, and point and location of 2. So here is a 5, and then it will be decreased by another 5 until location 4. Okay, that's how we draw the free body diagram. Now that's how we draw the moment. And based on these two, we can get our shear maximum is 2.5 kilonewton. Our moment maximum is 5 kilonewton meter. So that will be the maximum number we need to consider when design the beam. Okay. And also, one more question, because our moment diagram is above the axle, which means our beam will be bent like the happy face, okay, in this way. If the moment diagram is below the x-axis, which means our beam will be bent like the unhappy face, okay. So, well, let's take another example. So you have a beam with the loading as shown in this figure. Please draw the shear and moment diagram. So what we should do first is to draw the free body diagram of this beam and solve its reaction first. So first, let's convert the distributed load into a single load. Okay. AY, we have AX. This is 20 kilonewton. And we have BY. So the distance to okay, let's solve the reaction first. Okay. So far we have solved all the reaction. So next step, H2 draw the free, but H2 draw the moment and shear diagram. Okay. So as we discussed before, shear is the integral of the load. Okay. So it will be from 0 to 4. Our load is -5 dx which is -5, -5x bounded by 0, and 4, which means our shear diagram will move upside by 20. Its shape will be 1 mx plus b, which will be 1 -5x plus 10. Okay, let's show why. So it should be start from both 0, and because we have a, which 10 here, and then move down by 20, which will be -10, it's connected by a line. So that's a shear diagram. We have x, we have kilonewton, x, kilonewton meter. And also the moment diagram, okay, is an integral of the shear, which is here, okay. So our moment diagram is -2.5 x squared. So it will be start from 0 and ends with 0, okay. We can know the wave max 10 kilonewton, and the moment max is 10 kilonewton meter. So let's say example 3. So similar, let's draw the free body diagram. Here's A, here's B. We have BY, we have AX, okay. We have AY, and here is 8 kilonewton. Distance, this is 4, this is 1, this is also 1. See, sum of the moment equals to 0. By times 4 minus 8 kilonewton times by 5 equals to 0. By equals to 10 kilonewton. And also sum of the Fy equals to 0, which means Ay plus 10 kilonewton minus 8 kilonewton equals to 0. Ay is -2 kilonewton, which is downside. And sum of Fy equals to 0, we can get Ay is just 0. Okay, with knowing all those information, we need to get started with draw the free body diagram. Draw the shear and the moment diagram. Here's the A, here's the B. We have distribute load here. we have 10 kilonewton here, negative 2 kilonewton here, and here is our shear diagram. X in meter, weight in kilonewton. Vx, okay, equals to here is a Vx, how the Vx looks like on the right side of the B in the sum of the moment. Dx, okay, which is equals to negative 2 dx. So let's draw the free body diagram. For the shear, it starts from 0 to 0 and ends with 0. And for the A point, it has a negative 2 kilonewton. And let's move to the A point until point B. Move upward by 10, which becomes B8. Okay, and also this line will be negative 4x, okay, which will be just 0 here. For the movement diagram, start from 0. It's decrease like negative 2x until point 4, location 4, which is negative 8, will become back, okay, to in this shape. So the V max is 8 kilonewton. Moment max is 8 kilonewton meter. Okay. So that's pretty much for today's lecture. We will have more example next lecture.